Many solids take on an orderly structure in nature, and those solids are going to form crystals. The smallest unit of volume of a crystal, showing all the characteristics of its lattice, is called a unit cell. Unit cells are like the building blocks of crystalline solids. Unit cells will fit into one of 7 categories. Here are the 7 categories. Do not worry about memorizing these 7 crystal structures. The corners of unit cells are occupied by atoms, molecules, or ions, and then particles may occupy certain other positions, which result in 14 different crystal lattices. And on the back of page 9, I have included the 14 different crystal lattices. But again, do not worry about memorizing these 14 different crystal lattices. Most particles of the unit cell are not entirely within the cell itself. Some particles are at the corners, and those are shared by 8 unit cells. If they're at the corners, we're going to multiply by 1/8. Those particles that are lying on the edges are shared by 4 unit cells, so we're going to multiply those by 1/4. And particles on the faces are shared by 2 unit cells, so we multiply by 1/2. For example, the number of atoms per unit cell for a face-centered cube, if you go to the back of page 9 and you look at a face-centered cube, there are 8 particles on the corner, so we're going to take 8 times 1/8. There are 6 particles on the faces, so we're going to take 6 times 1/2. So the total number of atoms per unit cell, this is 1, this is 3, is 4 for a face-centered cube. Okay, let's look at a problem here. And I did change the wording of the problem from what it says in your notes. In the notes, I gave you the atomic radius. I changed it to the length of an edge, just to make the math a little bit easier. Calculate the density of gold. Well, density is mass divided by volume. Let's look at mass first. It's gold. The mass of gold from the periodic table, 197 grams per mole. Well, I need mass in grams per unit cell. So I need to get rid of moles. I can go from moles to atoms. It's an element, so there are 6.02 10 to the 23rd atoms in 1 mole. That'll get rid of moles. And to get rid of atoms, it's a face-centered cube. And we just found for a face-centered cube, there are 4 atoms in 1 unit cell. So this number right here depends on the type of crystalline structure that we have. So my mass, which is now in grams per unit cell, 1.31, 10 to the negative 21st. And to get volume, I need the length of the edge. It's a cube. The length of an edge is 407 picometers. The first thing I'm going to do, though, is take 407 picometers, convert that to centimeters. So pico means 10 to the negative 12th meters. And then I want to go to centimeters, which there are 10 to the negative 2 meters in a centimeter. So in centimeters, 4.07, 10 to the negative 8th. That's the length of an edge. To get the volume, I'm going to cube it. Length times width times height. So the volume of this cube, 6.74, 10 to the negative 23rd centimeters cubed. Because if I want density, I want mass divided by volume, and the density units are normally grams per centimeter cubed. And so I just take the mass, which I found, divided by the volume, and I will get the density of gold. We can classify crystalline solids into 4 categories depending on the types of particles making up the lattice. The 4 categories are included on page 10 of your notes, but we have molecular and covalent. Now these two are very similar. If you look at the type of substance produced by these two right here, very, very similar. Then you have ionic, which are metal, nonmetal compounds, and then you have metallic, which are metal elements. So these are the 4 categories of crystalline solids.